Hello everyone, my name is Nick. I'm going to be talking to you today about some IP addresses. If you don't know what those are, IP address, IP stands for Internet Protocol. Now we're going to be talking about version 4. There's also a version 6, which is something that they made a little bit later. And we'll talk about why they made version 6 and what IPv4 addresses consist of and why they're used. If you're already familiar with the IP address, then you can just skip through to whatever your part you need to get to. But an IP address is exactly what it sounds like. It's an internet address. Just like we have MAC addresses at layer 2, we have IP addresses at layer 3, which is the network layer. So let's talk about where it started. I'm not sure the full history of it, but back in the day, somewhere in the 60s, ARPANET created packet switching. Pretty much what they were 4 colleges who wanted to be able to share information. Now, in the 1980s, that's when IP addresses became a standard. IP version 4 became a standard somewhere in the 80s. That standard consists of 4.3 billion IP addresses. How do they get that number? Well, this is the range of IP addresses. So this is the dotted decimal format of an IP address. 0 to 255. 0 to 255, 0 to 255, 0 to 255. Now, if you're wondering why it's 0 to 255, it's because of something called an octet. Each one of these are an octet. They are comprised of 8 bits, which is why it's called an octet. So this is an octet, this is the octet, this is the octet, this is the octet. Anyway, each one of these octets has 8 bits in it, and this is known as binary or base 2. And that's the reason that it only goes up to 255. We'll get more into that in a second, but just thought it'd be something good to know so you're not confused as to why it stops at 255. Why not, 500 or 1,000 or whatever. So this is where the 4.3 billion comes in. There's 0 to 255, so there's 256 total options inside of each octet. You count the 0, so that's where we get 256, and then it's 1 through 255. But if you multiply 256 to the 4th power, that equals 4.294 billion, something in that range. So these are all the available IP addresses they made in 1980. This was the standard, IPv4. All right, so we're going to skip back to this next page so I can show you something. So this block here, this is known as classful addressing. Now, we don't go by this anymore. We use something called classless addressing, which we'll get into in just a minute. But this is what they used from 1980 to 1993, somewhere in there. And this is how they assigned IP addresses to companies and just different people. So back in these days, routing was different. Each device had to have a unique IP address. Whether it was in a private network or in a public network, they all had to have a unique IP address. They made these classes so that they could give out different size blocks of IP addresses. This class, 16 million. So if you get a class A address, say you get 11.0.0.0, then you get 16 million IP addresses to go with that. I think one company that Terry was telling me about that had a class A address block was HP. So they got a lot of addresses, a lot of public IP addresses. Let's say you got a class B address. Well, you got 65,000 different IP addresses, all public. let's say you got a class C. You got 255, or it's really 54 because you can't use the first and the last address, but still, this will be useful for a small network. Now, if you had that many public IP addresses, that'd probably be good for a pretty good sized network. If you're wondering why the we have the 255, that's just showing you the range of IP addresses you have. So right here it says 1 to 126. All the zeros behind it is where your individual like host IP addresses of 16 million. That's where you get the 16 million from. So you just do 256 times 256 times 256, you get that 16 million number there. That's how many host IP addresses HP has that are public IP addresses now. Here, 128 to 191. So the class B range is in the range of 128 to 191 in the first octet, 0 to 255 in the second octet. And the last two octets, again, 256 times 256 equals 65,000. Class C in the range of 192 to 223 in the first octet, 0 to 255 in the second, and 0 to 255 in the third octet. So they started giving these out to companies. They realized really quick that they were going to run out of IP addresses really soon, and they needed something to fix that. The reason they were going to run out is because everyone needed a public IP address to talk to each other, even within your own network, even within your company. You needed a public IP address to talk to someone else within your company. Definitely not scalable. So in 1993, they split it up. They reserved a bunch of addresses. Oh, by the way, if you're wondering why it stops at 223, and we just got through talking about how the octets range from 0 to 255, that's because there's two more classes. There's class D and class E. I'm not going to go over those right now, but you can look them up and see what they are. I think class E is experimental and class D is like some kind of internal address block, but I'm not 100% sure. You can definitely look those up though. Okay, so the reserved addresses. This is not all the reserved addresses, but this is the reserved private addresses. There is quite a few other address blocks that are reserved. You can look up IANA reserved address blocks, and you can see more information on that. Spelled like this. I think it stands for Internet Assigned Numbers Authority. So you can look up the IANA reserved address blocks and see more about that. But we're going to cover the private addresses. So these private IP addresses that they reserved for private networks back in 1993 were to slow down the exhaustion of us losing all of our IP addresses, the exhaustion of IP addresses. These addresses probably look familiar to you because it's what we use in our private networks. It's what you use in your house, it's what you use at your work, it's what the school uses. So rather than needing to use a public IP address for all your devices in your house's network, in your school's network, in your business's network, they gave us private IP addresses that we can use. Now, these private IP addresses are not routable over the internet. We can't use a private IP address to reach something on the internet. Private IP addresses are only for the private network so that your computer can talk to your colleague's computer. That allows us to save public IP addresses. It slowed down the exhaustion long enough for them to find something else to use, which is IPv6. We'll get into that in another video, but that was their solution to the IPv4 exhaustion. Now, if you're wondering, well, if we can't route it over the internet, how are we supposed to, talk to YouTube? How are we supposed to reach our email servers? Different things. If you're wondering that, you'd be smart to wonder that. And you can figure this out by Google searching RFC 1918. It's really popular. That is what they made in 1993 to fix the IP address exhaustion. And in this RFC, they state that we need a router on the edge This is I think they call it like a mediator. Um, so through the process of NAT, that router can change one of these private IP addresses into a public IP address on your exit interface that goes out to the internet. NAT stands for Network Address Translation. So your router is able to keep a log of all the translations from the different private IP addresses so that you're allowed to route over to the internet and pull up things like YouTube or your email or anything like that. And because of that, we were able to slow down the exhaustion enough to figure out IPv6, which, like I said, we'll get into in another video. Let's go back over here to this reserved private address block, and let's talk about this for a second. So these IP addresses are no longer public IP addresses. They gave them to us. They gave them to us to use in our private networks at home, at school. We got an address from the Class A block, Class B, and Class C. In Class A, they gave us the whole 10 address, the whole thing. So 10 dot anything, that's ours. Class B, they gave us a small range, 172.16 to 172.31. Class C, they gave us 192.198.0.0. Anything in that range, .0.0 to 255 in the last two octets, that's all ours. Now, if you're like I was and you're wondering, why'd they give us, like, why does it have two zeros there, but up here it says that it takes 3 octets? Well, they gave us the whole number, so 192.168. They gave us all of these addresses behind that. So no one can use 192.168. anything but private, except for on private networks. So before they reserved these for us, everyone had public networks. We learned that. I mean, public IP addresses, sorry. We learned that. Now, back then, routers were different. Routers knew that if it started with a 1 to 26, to 126, that it was a Class A address. It knew that there was the option for 16 million host addresses behind that. It also knew that if it was in this range, that there were 65,000 addresses in those last two octets, and those were the host addresses. It knew that was the host portion. It knew the first two were the network portion because of the range. Same thing with Class C. It knew that if it was in this range, that this was the network portion, and that last octet was the host portion. It knew there was 254 available hosts on that. Now in 1993, whenever they gave us the reserved address blocks, things changed. It was no longer classful addressing. It was classless, meaning we no longer needed classes to figure out what was the network portion and what was the host portion. This was called CIDR, classless interdomain routing. Now for this to work, we needed one more thing. We don't just need these IP addresses. The router has to know what part's the network portion and what part is the host portion. Now for routers to figure this out, it needed something called a subnet mask. This is what it looks like. This is a subnet mask. This is what defines what part of this address is the network portion and what part is the host portion. So that's all I'm going to show you today. If you want to learn more about subnet mask and subnetting, just look for one of my other videos where I talk about it, where I'll also be talking about the binary breakdown of IP addresses and how that works. There's two ways to view an IP address. There's the way the computer does, which is binary base 2, and there's the way humans do, which is just like this, called dotted decimal. We'll talk about that in the next video. Alright, I hope that you've learned a lot, and I'd like to thank you for watching.